So good evening everyone, Andy. Can you hear my voice? Say yes or no to me once. So type in the chat box and say that whether you can hear my voice or not. Okay, Andy, the last class I'm trying to reveal how these control structures are used part of your program constructions anyway. Yesterday I recorded one program. In that program, I used one switch case statement. I given small notes on switch case statement. So today let me continue like this. Right. So this workshop I'm concentrating on control structures directly or indirectly. I took a title known as logical programming in Java, and I'm concentrating on selection statement, iterative statements, and branching statements. Pending, I'll write today anyway. So whenever we want to learn or whenever we want to have clarity on the control structures available in the language, you must know the data types. Because of this reason, some time I took to give the parts, if not to reveal the types of data types available to you. According to Java language, data types are categorized into two types: primitive data types and non-primitive data types. Primitive data types means the data types which are existing in the form of single valued data formats. We call it as primitive. Non-primitive data types means the data types which are existing in the form of group valued data formats. We call it as non-primitive. Among primitive, we had four categories: integer data types category, float data types category, character data type, and Boolean data type. Among non-primitive, we had a class, interface, array, and enum. Like this, I given short recap on data types available in it. So I drawn one small diagrammatical form also for you, like this. So whenever I declare one variable int k is equal to 10, that is primitive data type declaration, int k. So one memory is created with 4 bytes. The memory is loaded with a single data value. So this diagram represents that primitive data type representation. This represents primitive data type representation. If we take one non-primitive data type here, this is non-primitive data type representation. Addition is one class which is declared with A, B, C and add components, 3 variables and 1 method. So in the process of creating object, class name AD is equal to new class name. Nothing but addition, AD is equal to new addition. Now what you observed in the RHS is nothing but one address location is created. By terminology in object oriented, we call it as one reference is created, 0x111. The reference is binded with non-static members of class like A, B, C, means getting 4 bytes for A, 4 bytes for B, 4 bytes for C, and some memory for add. Like this, all these 4 components are available at one address location 0x111, and the reference 0x111 is available on AD. Like this, 0x11 is accommodating group members, means one memory generated to hold group members. We call it as non-primitive data types or referential data type. Short recap on memory for primitive, memory for non-primitive. Then we have to go for control structures popular in all the languages. Anyway, everybody knows. To see in a single page, I written like this. Control structures. The structures which are controlled and managed by the programmers. So we are going to control it, we are going to manage it. We are calling it as control structures. Generally, these control structures are categorized into selection statements, iterative statements, and branching statements. Generally categorized into selection statements, iterative statements, and branching statements. So let me repeat one line under each. Selection statements anyway. The statements which are used to select some part of the program for execution based on condition is known as selection statements or conditional statements. So majorly under selection statements, there are simple if else, nested if, ladder if else, and switch case. These 5 you can say an examples of selection statements. Iterative statements or repetitive statements or looping structures by terminology you can say. You can call it as iterative statements or repetitive statements or looping structures. The statements which are used to select the set of lines of the program for repetition based on some condition, means some set of lines of the program are selected and repeated based on condition. We call it as iterative statements or repetitive statements. Majorly we show while, do while, and for. Of course, if we come to core Java classes, generally we train iterator, list iterator, enumeration, nowadays for each extended for like this. Lot more extensions came, but basic is nothing but while, do while, and for. These 3 are basic in your iterative statements. Branching statements, the statements which are used to transfer the execution control from one location to another location. The statements which are used to transfer the execution control from one location to another location, we are calling it as branching statements or control statements, branching statements, or you can call it as transfer statements. The major example comes under branching statements is break, continue, return, and exit. So I want to explain one among it. I took one switch case. Moreover, I want to give a information what this modularity concept means. So like this, I took this small big program indirectly. So let me explain that once. Now I saved this total program. Let me explain this program. The title I could not. Sorry, today's title is nothing but I am trying to explain the execution flow of above program, what it is generally. So after explaining this, I'll come back and read the notes, what has been happened yesterday. Okay, right. So then I'm scrolling back like this. Right. So like this, I saved the program, try to understand the flavor of this program once. I saved the program with I saved the program with prog.java. I saved the program with prog.java. prog.java. So whenever we perform compilation process, dot class files will come. Addition dot class file, subtraction dot class file, multiplication dot class file, division dot class file, modulo division dot class file. Anyway, your program 1 dot class file, like this 6 files will come. They are all comes under bytecodes. That is all bytecode. So the dot class file is nothing but prog dot class file will come. This one. Addition dot class file. Subtraction dot class file. Third one. Multiplication dot class file. Place not then I am writing like this. Division dot class file. Modulo division dot class file. Like this, every class component will have its own dot class file. That point you have to remember it. Every class component will have its own dot class file. So in your program here, addition one class component, subtraction one class component, multiplication one class component, division one class component, modulo division one class component. Now your switch case statement is supporting you to select any one. Your switch case statement is going to give a information. If not, the switch case is supporting you to select any one. Now see there. Imagine this is one execution environment. Draw here like this. Imagine it. This is one execution environment. Execution environment. So by terminology, according to according to JVM, Java Virtual Machine, this is Java stack area. Java stack area. So where your executions means the memory where executions are, means where the executions happens. So you can call it as execution area. Now for this execution area, first main method will come. This is also one method only. Main method will come for execution first. So imagine it. Main method is coming for execution. So main method is coming for execution. Imagine it. Main method is coming for execution. When the main method came for execution here, what is the first line available in the main method? Sir, scanner S is equal to new scanner. Imagine it. The scanner class in your Java language will support to communicate with input device keyboard, or it supports with the input stream actually. So there also we show one diagrammatical form actually. In the regular course and we show the diagram like this. Generally in the regular course, time will be very high to us. Comfortable times. Workshop only 2 days, no. Generally there we had some comfortable times. So we draw like this. So in the regular course, we draw like this only normally. 2 minutes. This is our architecture, JVM architecture. We try it. These are all regular class flows. Two minutes, I'm missing diagram. See there. We connect scanner class like this. See there. This is scanner class connection. This is scanner class connection. This is regular close diagram. This is scanner class. See there. Scanner class loading, object creating. The object is connected to operating system buffers. From there, the data are coming. The data are collected here. This is the data collection. And the data are moving here to here. Like this we show. Some flow will be shown to the student. That is normal regular class training we do. These are all flows only. So if you don't draw like this, the student may not understand it because these are all flows. These are all flows. So where then? So that much of time not available to us, no, normally here. So here you have to imagine it like this. One short recap again here. Very short time. So here the first line is scanner. Scanner will be connecting to the console input keyboard. Generally, where is that console input keyboard is connected now? Sir, console input keyboard is connected to virtual machines. Everybody knows that virtual machine will be under the control of operating system. So operating system will be controlling your IOs, input output devices will be under the control of operating system. So from there, if you want to collect the data according to object oriented, we had a scanner class. Imagine scanner class is collecting the data coming from the keyboard. So anyway, we are reading the data from the keyboard. This is the way of reading the data. Generally in your C languages, you'll write scanf %d address of A, you'll write means and of A. And of A means address of A. So there some concept is there for them. But here for us, we use the methods. Next int means call the int and take it and load it onto V1. Next int, take the data and load it onto V2. So finally, V1 and V2 are getting the values. Imagine it, V1 and V2 are getting the values. I am reading the data onto V1 and V2. Directly I am drawing it out. So V1 and V2. V1 and V2. I am entering 7 here. I am entering some 2 here. After reading the data onto V1 and V2, now I am showing the choice to the user. I am showing the choice to the user. You want which operation? Add a subtraction, multiplication, division, modulo division. Which operation you are in need? If you want add operation or addition operation, press 1. If you want subtraction, press 2. If you want multiplication, press 3. If you want division, press 4. If not, 5. So like this, I am giving a choice to the user which operation you want. Imagine he selected I want multiplication. He selected 3. Whenever he selected 3 now, from the keyboard, if he entered 3 now, I'll take this 3 and load it onto the variable. So the variable is choice now. So I'm loading onto variable choice. So I'll read the value onto choice. Imagine I'm reading the variable onto choice. Imagine I'm reading the variable onto choice. For diagrammatic, I'll draw up choice, one variable. Choice. Choice I entered 3 now. 3. After choice is 3 now, I had switch off 3. Now we are having a switch case statement. This is one selection statement. Based on the value choice, we are going to execute one option, or we are going to execute one choice, if not one case indirectly. Switch off 3. Here, switch off 3. Switch off 3. Here I had case 1, I had case 2, I had case 3. Now that switch off choice indirectly. Switch off choice. Nothing but choice is equal to 3 now. Right. Now that switch value is not matched with case 1. The switch value is not matched with case 1. The switch value is not matched with case 2. Because switch value is 3 now, 3 not matched with case 1, not matched with case 3, sorry, not matched with case 2, but matched with case 3. Whenever it has been matched with case 3, there are 2 lines available here. Multiplication ML is equal to new multiplication. Here I had multiplication ML is equal to new multiplication. Here I had system.out println ml dot mul of v1 comma v2. So this is the 2 lines available before this break. Now the switch value is matched with case 3. Now you have to execute the line known as multiplication ML is equal to new multiplication. So according to Java language, new means one reference is created. One reference is created. According to Java language, object oriented, no, right? One reference is created. Some 0x222, one reference is created. Because RHS, no, I'm drawing here reference. Now this new keyword or new operator should perform operation on multiplication. So among these 5 subclasses, multiplication will come for execution. Among these 5 subclasses, multiplication only will come for execution. Remaining subclasses will not come. Remember this statement. Only multiplication class will come for execution. Remaining subclasses will not come because new operator will say to execution control, I want one class with name multiplication because I want to create object for multiplication. So the multiplication class will come for execution. Multiplication dot class file will be loaded for execution environment. So once this multiplication class is loaded, so what this multiplication class is having? Only that multiplication, this is only multiplication. Only one method is there, int mul, int x, comma, int y. Here, int mul, int x, comma, int y. Now, one object is created. Now, for this, one object is created. Because new operator, no, after loading that multiplication class there, it creates one reference. At that reference, the multiplication method is binded. That will get the memory here now. So that multiplication method will get the memory here. Get the memory. Imagine I'm giving one number here. After that reference created, this is binded. Now this reference will come and load onto ML. This reference will come and load onto ML. Like this, one object is created. The object will have this address location. Sorry, that object will have the multiplication method, and the reference of that object is available on ML. After this line has been completed now, then the object is ready. This is object. This is object. Now, next line, ml dot mul. In Java language, dot means belongs to. So call the method mul which belongs to ml. Call the method mul which belongs to ml. So ml means here 0x222. Now we are calling this method. We are calling this method for execution. From where you are calling this method, the method is called from ml. ml means 0x222. We are calling this method. We are calling that method for execution. Now that method will come for execution here. That mul method will come for execution here. This mul method will come for execution. Int mul, int x, comma. Now, this method will come for execution here. Because execution area, no, you have to execute there only. That will come there. We give the same number 3 because calling only, no, total calling. The method came for execution. When the method came for execution, now we are passing parameters. This v1, I am passing parameter here. This v2, I am passing parameter here. I am passing v1 and v2 as parameters. Whatever the parameters I am passing v1 and v2, the parameters are taken by x and y. taken by X and Y. So the data are loaded onto X and Y. So X will take the value and Y will take the value. X will take the value and Y will take the value. X is 7 and Y is 2. X and Y will take the value. Now here I had a code known as RETURN. TURN. Return X plus Y. I had written X plus Y. Now X is taken here, Y is taken here. So it performs some action, addition action. After performing addition action, X plus Y will get 9. Whatever the 9 you got it, the value 9, result 9 will be returned to the method call. The result 9 will be returned to the method call. The value is returned to the method call. The value is returning back. The returned value will come for output. Y means print method is there, no? Print means output will come. Print means output will come. So I'm trying to explain the return statement now. Return statement, I made a statement yesterday. See there. In the above program, return statement is used to return the value after method execution, and the returned value will come back to the method call. In the above program, break statement means break is used to stop the execution of switch case and transfers the execution control out of switch case statement. Now, once the output came here, now break is executed. Whenever the break is executed here, from line number 63, control will come to line number 74. That's called branching. So break statement is used to transfer the execution control out of switch case. So watch it. So the break statement will transfer the control now because execution completed now, control will come out of your switch. So here selection statement, here switch case statement supported you to select one option from the multiple available options or cases, and return statement supported you to transfer the control from the method after method execution and transferring the result to the method call that you observed here. And break statement stopped your execution process of your execution process of your switch case and transfer the control out of switch case like this. In this program, I used break, return, and switch case I used. Hope you are clear, I think. Say yes or no to me. Are you clear? Now, so why we have to declare in a separate classes? See there. If we don't have these separate classes now, all the code will be loaded for execution. All the code will be loaded for execution. Right. Why we have to declare separate subclasses? If we declare separate subclasses, the required class and the required code will be loaded. Suppose if we take any C program and you can write all the code together, example. So I'm making some multiplication operation, but remaining code also will be loaded. If you write in a single program or single class. To overcome that, we write multiple subclasses, and which class is needed, that class only loaded, because only multiplication loaded, remaining addition, subtraction, division, modular division not loaded. That is the advantage of writing multiple subclasses. That is the information to you. So when you attend this object-oriented concept in core, we'll give more informations to you about this concept. So among the selection statements now, I used switch case anyway. So let me write one program on this whiles and do whiles. Let me write one line under it. Iterative statements. Let me write one. Okay, right. Right. So while looping structure, very popular now. While looping structure is very popular normally. In while looping structure, the condition is checked first. In while looping structure, the condition is checked first. And if the condition is true. In while looping structure, the condition is checked first. And if the condition is true, in while looping structure, the condition is checked first. And if the condition is true, then the loop block is executed. In while looping structure, the condition is checked first. And if the condition is true, then the loop block is executed. This process is repeated. Until the condition is false. In while looping structure, the condition is checked first. And if the condition is true, then loop block is executed. This process is repeated. Loop block is executed, full stop. This process is repeated until the condition is false. So for this, generally, syntax will be like this. While we keep one condition. Here, loop block will be there. block will be that. So in the diagrammatical form also here, in the diagrammatic form of this loop anyway. We draw like this. Here condition, here loop block. If it is true, control will come here. After loop block execution, again it check the condition here. And this process is repeated. This process is repeated until the condition is false. Until the condition is false. So this kind of structure we call it as while looping structure. While looping structure generally. So while loop is very popular anyway. I also will write one program to you, a small program to demonstrate while anyway. But I'll use one labeled loop, I'll use it for difference purpose. So how means example program, I'll take it. Write a program to read some basic salary of an employee and calculate the total salary. Roughly, in the process of calculating the total salary, some HRA will be taken, DA will be taken. So HRA sum 63% of basic salary, DA sum 43% of basic salary. Then whenever you want to calculate some total salary, we take basic salary plus HRA plus D. But your condition for the program is nothing but basic salary must be minimum 5,000. Minimum 5,000. So minimum 5,000. Now, whenever the employee enters basic salary less than 5,000, again you have to ask the basic salary. Repeatedly you have to ask the basic salary. So read basic salary until the employee enters correct basic salary. Read basic salary repeatedly until the employee enters correct basic salary. That's the code here. See how I am typing the program to it. 2 minutes. I'm taking one program here. Program 2. So here import java.util. Scanner S is equal to new scanner of system. I'm taking one loop while of true. I took the condition true only. I took while loop true. I took one while loop true. So the while loop never becomes false actually. Because I not yet used manual condition, I took true directly, while of true directly. So whenever I take while of true, it is a unlimited repetition generally. So, but I used one name for this while loop is XYZ. I used one name for this while loop is XYZ. I am calling it as label for this while loop. With this label, what I am going to do, see there. So system dot out dot println, enter the basic salary. Int basic salary is equal to s dot next int. I have to check this basic salary. Basic salary must be greater than or equal to 5,000. I am using if else condition here. I am using one selection statement here. I am using one if else. If basic salary is greater than or equal to 5,000, calculate. Else, repeat it. So here, so system dot out dot println invalid basic salary. If the basic salary entered greater than or equal to 5,000, now you take float total salary is equal to basic salary plus HRA plus DA. 63%, 43%. 63% means 63 divided by 100 into basic salary. So 0.63 into basic salary. In Java language, whenever you want to take a float, you must use F. For DA 43, 0.43 F into basic salary. Now, system dot out dot println total salary is equal to total salary message is coming out. So reading the data from the keyboard, this one actually. Scanner S is equal to new scanner. The scanner class internally linked to the keyboard. According to Java language, this object is linked to keyboard. From that object, if you want to read the data according to Java language, we had a method known as next int. Reading the int data. If you want to read float data, next float. If you want to read your any other data, double, next double. If you want to read byte, next byte. Like this, methods are there. In the regular training of core Java, we give the notes on this methods available from scanner, and we draw the internal flow of scanner. In a short in the short period today, so scanner class internally connected to one IO. From there, the data is coming into BSAL. Whatever the data entered into BSAL, I am comparing here. Now, once the output came here, you have to stop the loop now. Once the output came here, you have to stop the loop. Your output came now, you have to stop this loop. Because the loop will not be stopped now. Why it will not be stopped now? It is not condition now, I plus plus, I minus minus. I am not giving. So I am giving directly while of true. Always the while loop will be true only. So whenever my work is over, I must stop this loop. How to stop this loop means I'll use break. Break X, Y, Z. See there, I'm showing the second side of your break now. Generally, everybody knows break is used to stop the switch case. But break here, stopping the while loop. Break X, Y, Z means stop while loop. While loop name is X, Y, Z. It's called label. In Java language, we can give label to one while loop. You can stop that while loop directly. See there whether it is working or not. Let me check it. So let me run this program whether it is working or not. Java C program 2.java. Any error is there, it will be displayed there. Any error is there, it will be displayed. Somewhere I made an error. See there? I am forgetted double quotes here. Line number 16, I forget it double quotes. Right. Let me check once again. Now run this program. Enter the basic salary, 1200. Invalid basic salary, enter the basic salary, repeating it. The while loop will not stop. Until you enter your correct basic salary. 1100. Invalid basic salary, enter the basic salary. 1400. Invalid basic salary, enter this. Until I entered correctly, it will not end. At last, I am entering my basic salary is 12,000. Total salary is 24,720. So whenever my output came and as a code writer, I am stopping the loop. How I am stopping the loop means by using break. So break statement is also used to stop the execution of iterative statement using label. Iterative statement using label. Remember this statement and we can have control over the loop. So normally in other language, you know the while loop, no? I less than or equal to 10, I plus plus print I. Everybody will do that code. So other than that, what is available means I given small information about while. You can have one label for this while. You can have one name for this while. Whenever you had a name for this while now, whenever you want, you can stop that while by using break X, Y, Z. You can do it. You can do with break X, Y, Z. You can do like this. We can have a label for while and we can control that while loop. Where whenever we want, we can terminate that while loop. That's the information to you. Right. Sir, what about do while loop? One small information. In do while looping structure, the loop block is executed first, and then the condition is checked. In do while looping structure, the loop block is executed first, and then the condition is checked. If the condition is true, if the condition is true, then the process is repeated. The process is repeated until the condition is false. In do while looping structure, the loop block is executed first and then the condition is checked. If the condition is true, then the process is repeated until the condition is false. The syntax. So this is loop block. While, so some condition semicolon. Sir, why semicolon here means indicates that line has been terminated there. Means what? After while, body is not there. Body is before the while. That's the meaning. Now, this only we draw in diagrammatical form here to educate something. First, we do the block. First loop block. Then the condition is checked. If it is true, be repeated. The condition is true, the loop block is executed. If it is false, should be stopped. Stop means termination. If it is like this. So in the while looping structure, the condition is checked first, then the loop block is executed. In your do while loop, and first loop block is executed, then condition is checked. So which one is more efficient means generally while loop is more efficient than do while loop, because for false conditions in while loop block is not executed, but in do while loop block is executed for once, even for the false condition, and waste the execution time, because in real time do while is not preferable in all the situations. So always we go with while loop. So what is the difference means while loop the condition is checked first, then loop block is executed. Here loop block is executed first, then the condition is checked. Suppose for the false condition now, for the false condition in while loop, loop block is not executed for the false condition because the condition is checked first only. So loop block is not executed, it saves the time. But in the do while loop, and the loop block is executed, then it check the condition is false. So for the false condition, unnecessarily you executed loop block for once and wasted your execution time. Because of this reason, in real time, do while is not preferable. Always we take the support of while loop. So while loop is high performance when compared to do while loop. When we have while and do while, they introduced for. In for looping structure, in for looping structure, the initialization, condition and increment or decrement. In for looping structure, the initialization, condition and increment decrement are declared in the same line. Declared in the same line. Full stop. Sorry, comma. Which is more simple. In declaration. Which is more simple in declaration when compared to while and do while loops. The syntax is nothing but for initialization, condition, increment or decrement. This is one loop block. So all will be available in the single line. So a developer while coding, he can organize the code very easily when compared to while and do while. It's advantage. Now in the diagrammatical form, we show like this. So 2 minutes. So the look will be like this. Three parts like this. This is initialization. This is condition. This is increment or decrement. First, the control will come here. Initialization process first. After initialization, control will go to condition. Control will go to condition. If the condition is true, then the loop block is executed. Then the loop block is executed. If it is true, it is executed. After loop block execution completed, control will come here. So loop block is executed here. After loop block execution completed, it is incremented or decremented. Then after increment and decrement, control will come to condition. Like this, it repeats. So until the condition is false. Until the condition is false. So first initialization, then condition, then the loop block is executed. After loop block execution completed, it is incremented or decremented. After incrementing and decremented, again the control will check the condition. If the condition is true, repeated. If it is false, it is terminated. So this is the loop for looping structure. So everybody knows for loop based on this one program, small program. Lot more applications will do, and generally in the regular course, and generally I am writing normal programs because generally we'll do lot more applicative parts we do. Applicative parts will do. Anyway, known program, I'll write it. Write a program to display numbers from normal program. 1 to 100. So whenever you want to take this loop, and 1 to 100. One to 100 means the starting point is 1. So take one value. Int I is equal to 1. Initialization I less than or equal to 100. Ending condition I plus plus. Because you are printing 1 to 100. Increment. Just display this. So system dot out dot println print I some space. Small program. Initialization condition increment. So the program is executed. Printing 1 to 100, the loop. Now, the same program only, anyway, the same program only. For here. Using continue statement, I am going to skip it. To display 1 to 100, but skip even numbers using continue statement. So continue statement is used to skip the data, skip the iterations. Write a program to display the numbers from 1 to 100, but skip even numbers using continue. So here even numbers are there, no? 2, 4, 6. I'm going to skip it. So what are the even numbers now here? See that. If I modulo divided by 2 equal to 0, this is even. This is even number. Here I'll write continue. So whenever I write continue here now, whenever 1 comes here, 1 modulo divided by 2, condition is false. But 2 modulo divided by 2, condition is false. True. True means continue. Continue means skip this data and go for the next one. See there you can understand. So continue statement is used to skip the data. 1, 3, 5, 9, 11, 13, 15. See, I am skipping the even numbers by using continue. So continue statement is used to skip the iteration. Continue statement is used to skip the iteration. Now in the same program now, write a program to display the numbers from 1 to 100, but stop the program. Stop the program when the number is 33. Stop the program when the number is 33 using exit. Using exit. Write a program to display the numbers from 1 to 100, but stop the program when the number is 33 using exit. See that. Same program save as. Here, when the number reached to 33, here exit. But whenever you want to call exit, so system dot exit of 0. This is stop the program. Stop the program. Exit is used to stop the program. Continue is used to skip the iteration. Break is used to stop the loop on some label. Break is used to stop one switch case. Return statement is used to return the value from one method to another method. These are branching statements. While, for, switch, if else. Remaining on demand, when the code comes, we can write it. That's a theory. Right. Let me run this program once again. I saved the program with program file and running with program file. So whenever it reached 33, it stopped. So first one is loop, second one is continue, third one is exit. So exit is used to stop the program, continue is used to skip the iteration, break is used to stop the loop on label, or you can stop the switch case statement. So the theories. And you had one program on while and for, this is less used. So more number of programs we demonstrate part of your regular courses. This program is short information about them, short info, very short, and we do very much in your regular courses. I am free by 4 p.m. I took one small 2 hours time. I took it out, very less time. Okay, right. So thank you very much. In the coming workshops, I'll take one small class again based on technical questions or technical codings. I'll take it out in the coming workshop. So now roughly I'm introduced few control structures to you. Thank you very much for today, Andy. Thank you very much.